All right, so for exercise 11 here, I have bad news. If you thought exercise 10 was tough, exercise 11 requires, and even just looking at this, I already know is going to require an extra jump in logic than what we did already. So the good news is it's asking us to write a function diamond n, which returns a diamond where the triangle formed by the top portion has a height of n, meaning this right here, it should be equal to 5 if we call diamond 5. And so the bottom part of the triangle, everything beneath that, should be equal to another triangle, an inverse triangle of 4. So if you ignore this stuff down here and just look at this top, what you can see is all we're doing is just drawing a triangle like we did for the last function, and then having to figure out how to make this decreasing triangle below it. But we already know how to draw this top triangle, right? And it's just drawing a triangle, and we wrote that code already. So copy in your spaceline code and your triangle code to get started, because we're going to use our triangle function in order to build this diamond. So if you haven't done it yet, now that you know that you need to use spaceline and you know that you need to use triangle, try to go through this and figure it out, okay? If you need a little bit of help, more help, keep watching. So what we're going to do is now I'm going to write my definition for diamond, and it's going to return a multi-line string of hash characters in the shape of a diamond with n lines from the center line. No, that's all right. With diamonds with n height from top to center. That's maybe not as clear as it could be, but it'll do for now. So the first thing we want to do is create our diamond string, right? Because we're going to be doing it the same way that we've done all the other ones. We're going to create our diamond string as an empty string. And then, to draw that first half of the diamond, it really is as simple as just calling triangle, triangle n, right? So right now, what we have here is saying, okay, if I tell it to draw a diamond of n height, it's going to create a diamond string, and it's going to make that diamond string equal the string that gets returned by triangle n. So if I just go ahead and print out diamond 5, you'll see that what I get already looks exactly the same as triangle 5, but also looks exactly the same as the top half of this diamond. So we're already halfway there. Already half finished with this exercise, and all we did was copy our code from before, our functions that we used before, and added in 2 lines of code, right? So we're already almost there. Now, unfortunately, we have to figure out how to make this bottom half, and that's going to be a little bit tricky. If you want to try to work on it yourself, now that I've shown you how to get the top half of the diamond, what you need to know is that you're going to be using a for loop, you're going to be using a range function, and you're going to have to set that range function up so that it counts down backwards. So if you don't know how to do that, go back to the sections in the chapters before on range and how range works, so that you can, or go look it up in the Python docs, so you can get a for loop that decreases down rather than increases up. Alright, so if you're still here, great. Either you figured it out or you need the extra help. Either way is fine. So if we want it to increase up, all we would need to do is do for I in range n, correct? So that is essentially the same as writing for I in range 0 n, or for I in range 0, 1 n, right? So actually, when we write for I in range n, what we're actually writing is a shorthand for I in range 0, 1 n, which says, hey, start range at 0, increase it by 1 every time, and stop it when it hits n. Actually, I wrote this wrong order. This order is what it works the same as. So I can demonstrate that by doing this and doing we'll just add A's onto the end. So what this should do in this case of what we have down here with print diamond 5, it should give us now 5 A's added on to the bottom row of our diamond here. So there you go. See, 5 A's. So that's a range going upward. Now we can also set it so where the range goes downward, right? But if I run this, it's going to have a problem in that it's going to start at 0, it's going to go backwards, it's going to decrease by 1 every time until it hits in. But if we do that, it's never going to hit in, right? It will just never hit in, so it will actually run infinitely. It'll make it an infinite for loop, which is, we don't want that. Instead, what we want is we want it to stop when it hits 0, and we want it to start out at in. So this will still get us 5, but instead it's going to take in and increase. It's going to start I being equal to in, and then it's going to decrease I by 1 until it hits 0. So it'll still get us 5 A's. It'll still look exactly the same, but we know that instead of I getting bigger, instead this range, this for function, is making I get smaller, which is going to help us draw our shrinking triangle along the bottom here. So if you haven't figured out what to do now that I've shown you how to do the negative for loop, the decreasing for loop with the decreasing range function, go ahead and try it out now. Okay, so if you still haven't gotten it, the answer is pretty simple. And it's going to be another usage of this. So it looks exactly the same as our triangle code above, where we're setting each time through diamond string equal to space line, diamond string equal to itself plus a call to space line of some number of spaces and some number of hashes with an n at the end. So let's take a look at our example to see how we need to set up those spaces and hashes. So for the first time through here, we know that I is going to be equal to n. So I will be equal to 5 the first time through. So let's take a look here. So if this is equal to 5, what we have here is 1 space and 1, 2, 3, 4, 5, 6, 7 hashes. So that's going to be the same thing as the inverse of this above. So how did we do this line above? Because all we're doing is the same thing down here, just in reverse. So for this line above, it was n minus I minus 1 and I plus 1. So let's see if that works. Let's just see if it works. You know, if we make it work the same essentially in reverse, if we want it to work essentially the same as in reverse, and all we're doing is changing what happens to I, it's getting smaller instead of bigger, it could just work if we just copy the same values. So let's see if it works. All right, that's close, right? That's almost right, but not quite. So what's happened here? So 1, 2, 3, 4. Okay, so the issue is here that we're not getting the spaces that we want down along here. We're also getting 5 lines down here, 1, 2, 3, 4, 5, when really we only want 4 lines. So that's our first indication that something's wrong. If we're getting 5 lines instead of 4 lines, that means that instead of starting with I equal to n, we should start I equal to n minus 1, so that we only get 4 rather than 5. So that was an easy mistake to make, but now that we've caught it, we've got, at least it's printing, so still not right, but at least it's printing the right number of negative lines here. It's printing 4 instead of 5, which is what we want. So let's see if we can fix those lines. It looks like each of the lines is 1 too big. So there's 1 fewer spaces than there should be, and there's 1 more hashes than there should be. So we can, if we take out an I here for the hashes, what happens? If we take out one of our I's, what do we get? Okay, so that's not going to work. Or potentially it will. Let's try to also do the same thing for our spaces here and just see what it looks like. So now we're just kind of trial and erroring it here to see what happens if we change stuff around. So spaces are currently set to n minus I minus 1. So what if I get rid of that minus 1? What happens? It should give me one extra space, because if I take out a minus 1, that means that we should get one more space than before. So that is what we wanted. We wanted one more space. Okay, good. So when I took out that I, it caused a problem. So I'm going to put the I back in over on my hashes side of the equation and then run it and see what I get. Okay, so it's still not what I want. I'm still getting, let's see, on this line I'm getting 2 too many. On this line I'm getting 3 too many. Is that right? No. 2 too many. On this line I'm getting 2 too many. And on this line I'm getting 2 too many. Well, that's good. That means that we're getting two that's a poorly phrasing. We're getting 2 more hashes per line than we expect to get, than we want to get. So if I take out this 1, what happens? Okay, close. We're still getting too many hashes per line, but now you can see that we're only getting 1 extra hash per line. Well, if we're getting 1 extra hash per line, how can we get rid of that extra hash? And the answer is simply just subtract 1 hash per line. In our call to the function, just subtract 1 hash per line. So what we get instead is this, and it's the correct diamond, right? This is right. So let's see if we can figure out why that worked. So for our number of spaces, I should have known this, but each time through, our I starts being equal to 4, right? Which means the first time through, if we had it set to what we originally had it up here, it's going to be 4 minus I, which is it's going to be n, which in this case is 5 minus 4 for I. So it's going to be equal to 1 minus 1, which is going to be equal to 0. So the first time through, it's just going to give me 0 spaces. The second time through, n is still equal to 5, and I has decreased to 3, so it's going to give me, it would have given me 5 minus 3 minus 1, which is only 1 space, which is obviously not what I want. I wanted, instead of 0, I wanted 1. Instead of 1, I wanted 2. So I should have known that each time it was giving me 1 fewer space than I wanted, and then I could have just removed the 1. For this other part, really all it was realizing that with the way that this is set up, it's set up to draw a line for a diamond that is the same as the number n. Right? Essentially, it's setting it up so that it draws a line for the diamond, that a line for a triangle, because we copied it straight from our triangle code. It's set up to draw a line from a triangle that is drawn when the I is equal to the kind of number of n that we have. But because we changed it so that instead of being equal to n, it starts off equal to n minus 1, it meant that I need to make the change here where I just took off those extra hashes that resulted. Because each time through, the way we had it written before up here, it was written to give us essentially 2 extra hashes for each time it increases the line. So the first time through it gives us 1 hash. The second time through it gives us 3 hashes. The third time through it gives us 5 hashes. It's written to increase by 2 each time. So if I wanted to set it so where it was 1 line less than it should be, I needed to subtract 2. So plus 1 becomes minus 1 by subtracting 2. I don't know if that makes any sense. I know it's confusing. I know it's hard. But if you got here, you got to this point, at least feel satisfied that you understood some of this, right? It's meant to be a tricky problem, but generally speaking, the problems that you're going to be solving won't be kind of this obtuse, right? They'll be, generally speaking, more concrete than this, more specific than this, more obvious than this. So if you did bad on these exercises for this chapter, don't feel bad, okay? You got here, you got through the chapter. We're moving on to some easier stuff after this, so don't worry about it.